When using the Circulator Energy Savings Calculator, it's a good idea to start on the README tab, which I have open here. So there's two tabs, the README tab and the Circulator Savings tab. The README tab has a lot of good information about how the calculator works, the underpinning data, where it's coming from, and how that calculation methodologies are sourced and proven. The Circulator Savings Calculator, its real purpose is to support uniform savings calculations based on the HI energy rating label, or if you don't have a label, it can calculate savings based on the size of the circulator and its controls based on what's available in the HI energy rating database. So since the energy rating is a primary data source for the calculator, let's just really quickly review on the right-hand side some of the important items from the label that are going to be used. So the calculator is going to ask for the weighted average input power, which is on the top right-hand side of the label. It's going to ask for the Circulator Energy Index, or the CEI, again, which is in the black bar. It's going to ask for the energy rating, which could be a single rating or a range, a high and a low range. So if you have a label, it's going to ask for those. If you don't have a label, it's going to ask for the horsepower of the circulator. So you need to know, a little something about how the circulators are rated horsepower-wise. And it's going to ask you for the onboard controls. So you can select one of the controls, which again is circled there in red. So with that, let's go ahead and take a look at the Circulator Savings Calculator and click on the Circulator Savings tab, which I've just done. If you're using the calculator and you find yourself on this tab, there are also relevant instructions over here on the right-hand side for quick reference on some of the assumptions and data underpinning it, but also how to use the calculator. The first time you use this calculator, the first time you download it, you may get a button that says Enable Content, and you'll have to click the Enable Content button, which essentially enables macros that are within this calculator. So that button would be at the top of the Circulator calculator. Following that, you can click the Update Calculator Information. And what that does is it then connects this calculator with the energy rating database, and it pulls in the most up-to-date energy rating information. So if you want to do calculations without having an energy rating label in front of you, it has the most up-to-date information on efficient circulators that are available. Now, you can also do calculations without being connected to the internet. It's just going to use data that was embedded when it was downloaded or the last time you connected it to the database. Now, as far as doing calculations, it's fairly simple. Cells in yellow are going to require data. Gray cells are not going to require data. And blue cells are going to be optional. Additionally, when you're looking at the calculator, if there is a red triangle in any of the cells, you can hover over it and it will provide additional information about that cell and what it means. So let's go ahead and run through our first example. In this example, we're going to indicate that we have an energy rating label, and you'll see that some of the content here has gone gray, so we're not going to use it in this calculation since we have an energy rating label. We're going to select the application, which can be hydronic heating, domestic hot water, or other, and this is going to use different run hour considerations and load profiles depending on what you pick. So for this one, I'm going to pick hydronic heating. We also want to pick the sector, so we can pick residential or commercial. For this, I'm going to pick commercial, and again, that will indicate the default run hours. So since we indicated we have an energy rating label, we want to put in the values. So in this case, I'll have a minimum value of 150, a maximum value of 180. The weighted average input power. Again, we're going to get this from the label, and that's circled there on the bottom right label. So I'll just use that value, 0.068. The circulator energy index, which is 0.6. And then as we move down here, again, since we selected hydronic heating, the domestic hot water information is not entered and not going to be used in the calculation. Now we have an option. We can input the operating hours if we know them, or we can use the default value for the application. I'll just leave that as default. We can also then update the electricity cost based on either the average for the state or put in a specific value down here. I'm going to go ahead and put it in for the state. So this one, we're working in Alaska, and that brings in the higher 20 cents per kilowatt hour. If you're not in the United States and you want to use this, again, I would encourage you to just type in your electricity cost here, and that could be any value in dollars per kilowatt hour. And then we have an option to put in the cost of the circulator. So the cost here that you put in, it could be the total cost of the circulator, or if you were doing a comparison of two circulators, say I had a new application, and I could pick circulator A, which is your typical permanent split capacitor type, or B, which is the ECM type with controls. You could just put in the cost difference. Okay, so for this, I'll put in just a cost difference. Let's say it's a $100 cost difference, and down below we can see the savings calculations in kilowatt hours per year, dollars per year, and the simple payback. So with everything entered here, by going to the more efficient circulator pump, we're going to have a payback in about 2 years, right? And these pumps last 10 plus years, sometimes much longer. So communicating the value of choosing the efficient circulator pump.